as our inaugural meeting. We very much appreciate you being there at the start. I tell my team that you get most of the credit for the first draft. That to go from the tyranny of the blank page to the something is an act of enormous creation. And we're going from not having a community to having a community. And you guys are there from the get-go. That's all I have. I want to say thank you again. We're excited. We appreciate the work you do on our system. And it's, again, for researchers and inventors like you that we build these amazing machines. Thank you. Have some fun. And we look forward to engaging at multiple levels over the weeks and months to come. With that, I'll hand things back to Uday, and we'll kick the program off. Thanks, everybody. Be well.
Hey, thanks, Andrew. Appreciate the words. And also thank you to everyone for taking time today to attend our first developer community meeting. I'll reiterate Andrew's words and say that I'm also really excited to kick these series of meetings off and very excited to see what our community can build together. Before we get started, I just want to quickly share the agenda for today. We'll first introduce those that helped create this event, share with you why we created this developer community and why we believe you should be excited, and then describe the various resources we offer to developers. We'll go into more detail into our ML software and go into more detail into our SDK software, and then conclude with a discussion on what's on the horizon for Cerebras in 2022. So this meeting was made possible by the collaborative efforts of some of our organizing members. So we like to call them out right now. Pittsburgh Supercomputing Center, Argonne National Laboratory, Lawrence Livermore National Laboratory. Thank you for all your help. And today you will hear or in the chat interact with some of the Cerebras members. Rebecca will be moderating the chat. Samia will discuss ML software. Justin will discuss SDK, and Natalia will share what's on our horizon. So why did we create a developer community? Well, we really want to help all of our users stay up to date, meet our community, and learn and get help. So with these meetings, you should expect to hear about release announcements, recent publications, and then other activities that are happening in the community outside of this one. Additionally, we hope that you use this as an opportunity to network and engage with other users of our system and learn about what interesting work they've been done and hopefully share your own. And finally, we expect this community meetings to evolve to turn into training sessions, providing you the ability to ask questions and get answers to frequently asked questions, and provide your own feedback that'll help us pivot and iterate on our roadmap. So just to kind of hammer down on this, what you can expect in future meetings will be technical deep dives, research presentations, guest lectures, maybe even yourself being a lecturer, competitions, and hot topic discussions. If you're interested in a specific content or in participating in a future meeting as a contributor, please feel free to email us at developer@cerebras.net. That's just one way you can contribute. Going from low effort to more effort, there are many ways where you can contribute. Simply by attending like you did today is one way. Asking questions in the chat. And just to note that at the end of this presentation, we'll leave some time for Q&A. We'll also, at the end of this, provide a link to a survey that you can fill out for us and help us with. And then finally, you can also answer questions from your peers, share your preliminary work, and even lead a training seminar if you'd like. With those said, please note that this community meeting should not be considered or should be considered a public forum. So please don't share confidential information unless it's been approved by your organization. All right, moving on from logistics to more of the fun stuff. Cerebras offers a few developer resources that we'd like to talk to you about today. For the ML developers that are in attendance, we offer our implementation, which is public references and our private model zoo. We also have our ML software, just layered on top of TensorFlow and PyTorch framework. And for our kernel developers, we have our Cerebras SDK. At this moment, I'll pass this to Samya, who will talk a little bit more about the ML software.
Thank you, Uday. And hi, everyone. I'm very excited that we have a forum like this where we can all talk about our features and one-to-one on the developer front. So to give a brief overview of the ML software here, I think many of you are aware and have been using at a very high level on the network architectures. We've been primarily focusing on the transformer style models, mostly the encoder-decoder styles. We have supported BERT and its variants, Roberta, our basic transformer models like the attention all you need, and going forward with the T5 as well as GPT-2 and so on. So there are some of the transformer models that we support, but this is just a limited list. There are more models that you can explore and work with our ML software. At a basic level on the multi-layer perceptrons, we also support FCNS, which is more like our Hello World sample to begin with and try out our workflow. On the framework side, we support two most popular ML frameworks, TensorFlow and PyTorch. TensorFlow, we've been supporting mostly through their estimator API. So we have a nice wrapper class, which leverages the TensorFlow estimator. And with simple few lines of code and a user-friendly API, we are able to help TensorFlow users to use their current estimator code and port it all the way and run it on our Cerebras systems. On same lines with PyTorch, we have leveraged the XLA backend and also used the lazy tensor way, just because how given our wafer scale engine, which is pretty huge, we need the full graph to be part of what gets mapped onto the wafer scale engine. So lazy tensor is the best fit for us to support the PyTorch models. And we have done exactly that and have been working with the MLIR community as well. And we are focusing on how to make this more usable for the users. On the feature side, as you would expect, we support train, eval metrics, predict the inference on some of these models. Pre-training and fine-tuning are both different aspects of the training that we support. So it's not just from training from scratch or pre-training, but also fine-tuning aspects. And as one can imagine, the input pipeline is one of the key aspects in any training workflow. So optimizing that input data pipeline and making it more seamless to optimize it is one of our key features. And we do release separate scripts to do exactly that. And also we have these kernels, which we want to generate more automatically, especially for the non-linears and the losses like softmax or Celu and so on. So this helps us to really get those kernels automatically generated to map to our wafer scale engine. So these are some of the features which really help in taking the best utilization of our wafer under the hood. Finally, ours is a big chip, yes, but then it's not only for the big models. We also find a way to execute the smaller models more efficiently and with a lot of performance. And for that, we have this mode called multi-replica, where we typically take multiple replicates of the same model, map it to different parts of the wafer scale engine, and run it using the data parallelism. Just very similar to how a multiple GPUs would be connected and run through data parallelism. Here, the difference is everything is run on the same chip, so it gives us thousands of orders of the performance improvement. Finally, on the execution modes, we have two primary execution modes. One is the pipeline execution mode, where the entire model gets fitted into our wafer scale engine. So we keep streaming data, but execute the entire model at once. That way, this is mostly applicable for those models which are under 1 billion parameters. As you can imagine, they fit very well in our 40 gig of on-chip memory and helps us to boost that performance. But of course, in real life, there are models bigger than this. So for that, late last year, we announced a new technology called weight streaming technology. This is our groundbreaking technology where we consider mapping a single layer onto the chip, but really streaming the weights while we have the activations on the chip. But given the sheer size of our hardware, we can still map the whole layer onto the chip, so there's no layer sharding needed. And with decoupling the whole memory data and the model, we are able to increase the model size and the training speed at the same, more in a disaggregate manner. And with this technology, our aim is to support models like GPT-3XL, GPT-J, Megatron, and any huge models with billions and trillions of parameters. That is where the future is going. Okay, it's very exciting that today also happens to be when we released our ML software 1.2 version. And this software version is very important for us, mainly for two reasons. One is we have significantly expanded the PyTorch support, as some of you might have been using our software from past. So we've been predominantly supporting TensorFlow and minimal on the PyTorch, but now we've been focusing more on PyTorch. So this release really brings out a rich set of NLP models in PyTorch. We support train, eval, as well as long convergence for these models, which include BERT and many variants, the BERT tuning, which is the NER format, and also the transformer T5 and GPT-2. Alongside, we have also improved the workflow for porting easily the existing PyTorch models so that it's seamless to just run on the CS2 and follows very similar workflows that you're probably already familiar with TensorFlow. That way, the switch for those who have already used our software before is super simple. And for those who are using it new, our code really requires very few additional lines of changes on your existing PyTorch models. So that way it should be still more simpler for you to run it on CS2. The other aspect that this release brings is the initial release of the weight streaming execution. This is the first time we are bringing out a functional support for the extreme scale models. This release specifically supports the GPT-3XL with 1.3 billion parameters, and it can be run on a single CS2. And we're looking to expand and continue this work to support more models like GPT-J and also across CS2 clusters in coming future releases. Few other noteworthy additions here. We are trying to include the multi-replica support for smaller models like BERT-based. And we've also added TensorFlow Linformer model, and finally a CS input analyzer script, which is an offline script for optimizing your input data pipeline. We understand that's the place where most bottlenecks come, and hence we worked on this offline script so that we can help you determine the most optimal worker nodes in a CS cluster that you would have to spin up. Can we move to the next slide? So with resources, we have our documentation. It's a pretty detailed work that we have done here, try to give a good exposure and a flair of all the different concepts for our software as well as underlying hardware and how the technology is made use of. And at the same time, gives simple use cases and workflows and tutorials, how you can get started with your models on these TensorFlow and PyTorch. And on the side, we also have the Cerebras reference implementations, which are the sample model references that we provide. We also have a public repository here with few example models and a lot more expanded set of models through our model zoo for where you're already probably using it. So please feel free to explore these resources and get started on our ML software and reach us out if you need any help from our end. At this point, I'll hand over to Justin to cover more on the SDK side.
Thank you, Soumya. So my name is Justin. I'm our product manager for the SDK. I'm incredibly excited to see so many of the SDK developers in this forum. So I'm looking forward to describing our SDK and our future plans here. Just to give a brief overview for those who haven't used the SDK or for those who have, the SDK is the way that you can program a Cerebras system at a lower level than TensorFlow or PyTorch. So strictly speaking, it's a general purpose parallel computing platform and set of APIs that allow you to write kernels for our CS1, CS2, or anything in the future. It consists of these three main components, starting with languages. So we have our Cerebras software language, also known as CSL, and that's how you program the device. And on the host side, for running on the CPU, we provide a set of APIs. Right now, these are in Python. And also in the future, we'll be building out very soon a set of libraries to abstract a lot of the low-level capabilities of our hardware. This includes things like BLAS libraries or collective communication libraries, and these give you pretty rich functionality, so you don't have to get to the very low-level parts of the SDK. And the third component of this is tools. So we provide, as part of the SDK, this cycle-accurate software simulator. This allows you to run programs against your own local environment, so you don't need to have real hardware on you. We also provide debugger, performance profiling tools, and visualization tools. And on the right side here, you'll see the first iteration of our visualization tools, which allow you to view some of the low-level routing, look at instruction traces, your source code for any given PE, wavelet traces, and we'll be expanding functionality there, of course, moving forward. So next slide. Yep. So at a very high level, how the SDK programming model works is you have one or more host CPUs and your CS2 device, and the host CPUs right now are running Python, and the device is running CSL. So on the host, you'll be loading programs onto either the simulator or the CS2 system. You would stream in data in and out from one or more of these CPUs, and you would read and write to the device memory. And on the device side, as the programmer, you're targeting one or more groups of cores, and those cores are running what are known as data flow programs. So next slide. Yeah, so as part of the SDK, this is actually a sneak peek of what's coming in 0.4. This is our simulation GUI debugging tool. We provide a visualization here similar to the 0.3 version of this tool, and we'll be releasing a new feature in the GUI, which as at the bottom of this picture here, you'll see a timeline. This gives you a visual representation of data flowing in between PEs. So you have a much easier time debugging maybe some performance bottlenecks when any given PE is running. So next slide. This is the last slide on coverage of the SDK here. If you are one of our beta users right now, we provide access to a very comprehensive set of documentation. This is at sdk.cerebras.net. This provides access to tutorials, example benchmark kernels, really everything that you need to go from beginner to intermediate and advanced level programming using the SDK. Next slide. So ending off on what's new in SDK 0.4, which is going to be coming out at the end of this month, and also what's coming beyond 0.4. So in 0.4, we'll be releasing some new command line tools. This includes CSDB, which is a debugger tool for running on hardware. And we'll also be releasing a readelf tool, which gives you very low-level inspection capabilities for the binaries that you would run either in simulation or on the CS2 hardware. We're also, as I mentioned, we'll be releasing a new feature in the GUI. It's this timeline capability. And we expect that to be very useful for anybody who is tracing information that's passing between PEs for communication or debugging bottlenecks. We're also releasing an HPC kernel GitHub. So this is where we'll be putting all of the benchmarks and examples, and we'll be updating this constantly. And we would expect that folks like you, developers, can also contribute to this GitHub for any work that you may be working on in the future that you want available to members of the community. As part of 0.4, we're also making some compiler improvements in our CSL language. We're enabling higher performance features with those improvements, and we're making a lot of bug fixes that might have come up that some people might have encountered in the past. And so beyond 0.4, this is just a sneak peek of some of the things that we're working on. We're currently working on a native CentOS package so that you don't have to use a container to interact with the SDK. You can run it natively on your system. We're releasing benchmarks. Two are provided here as examples: a sparse matrix vector multiply and matrix multiply kernel. And we're also releasing our first library, which is a collective communications library to abstract a lot of the low-level routing that you might be doing right now. We're also releasing a high bandwidth mem copy so that you can do maybe some streaming applications in between your host and device, or getting much higher bandwidth data transfer between the host and device. And we're also going to be adding some C++ host APIs instead of just Python. We'll be adding functionality in CSL to do dynamic or runtime routing. And we'll be releasing some more performance profiling tools.
Okay, I think at this stage, let's probably turn into discussion, ask questions. I see there was a lot of conversation chat on in the chat, so let's.
Yes, this is Rebecca. I've got some stuff queued up. Do you want me to just ask? Okay, so the first one I've got is from Mohammed Ozturk. He was asking if we have a future plan for the a CSL backend for PyTorch and TensorFlow. As in, can we extend the backend custom operation of PyTorch/TensorFlow in CSL this year? I think this was answered in the chat, but I think it's worth a longer answer.
Yeah, I can talk to this unless Samia, you want to.
Sure, go ahead and I'll chime in.
Yeah, so we don't plan this year on releasing a CSL backend, although we know lots of folks want to write custom deep learning or an AI kernels for TensorFlow and PyTorch. So this is something that we're thinking about. And I think I'll leave it at that. But Samia, if you want to chime in with anything else.
Yeah, I think that summarizes well. So our plan is currently to focus on bringing up a wide range of different models in our primary network architectures at this point, but we also provide SDKs so that users have this flexibility to explore some at a more kernel level and code it to our architecture. Having said that, I think next year is sometime where we might start looking at how to give this support for a custom layer implementation and support the TensorFlow and PyTorch backends.
Okay, people on the call, chime in if you're not liking these answers. We'll iterate on them. So next one from Iwata-san. Is the model zoo also updated along with software 1.2?
Yes, so we have also updated Model Zoo 1.2. It should be available today, but again, it is dependent on when your CS systems get upgraded to 1.2.0 ML software. But having said that, you can clone the latest Model Zoo today, go through some of the latest model implementations that we have released there and get familiarized. And finally, when it's time to run, please work with your system administrator to get that going. Apart from the Model Zoo, from this release, we have also released a public version of a few sample models. So if you want to just understand and browse through our user workflow, there is the Cerebras reference implementations GitHub repo, which is completely public and it doesn't need any specific access constraints at all. So you could, if you don't have access to models, so feel free to browse through the reference implementations and hit us up with questions, or if you need to explore more models from the Model Zoo.
Thanks, Sammy. Yes, I shared a link to that in the chat, and we'll also share it in a minute, and we'll also send out a note after this call, so no one should be short of a link or three. Next one from Dennis Acherov. Forgive me if I'm mispronouncing that, Dennis. Any plans to support generative models, particularly variational autoencoders, gravitational networks, etc., with applications in computer vision and related scientific applications?
No plans to support GANs this year. We do have very limited support for variational autoencoders, so we can see what can be done with existing kernels.
Okay. And another one from Iwata-san, and this was answered in the chat too, but I think it's worth, again, a longer answer. Does weight streaming require additional hardware like MemoryX and SwarmX? Maybe just kick off by reminding people what MemoryX and SwarmX are.
Sure. Yeah, so for weight streaming, we are working on a support cluster specifically that involves the memory aspects as well, and which will be really important to get the best potential out of our weight streaming technology. But what is getting released now in 1.2 is really the initial release, and this release is mostly intended for early experimental use on your CS2 systems. So the CIF containers that we deploy with the 1.2.0 release can also run in compatibility mode for the weight streaming aspect. So in the existing standard pipeline mode, so you can still run the weight streaming GPT-3 XL with 1.3 billion, that model that we have released. In our coming releases, we will be releasing more information on the support cluster that's needed to get this weight streaming technology more up to its full potential. Maybe Natalia, you want to add anything to that?
Yeah, I'd like to add and provide a very simple answer. So if you want to run across a cluster of CS2, you need SwarmX. There is no way to get to distributed setup without SwarmX. If you want to run models beyond maybe a couple of billion parameters, you need MemoryX. If you want to run a single billion parameter model, we can run our weight streaming client software on existing support cluster. So essentially, MemoryX is needed when the model becomes that large that it can't be fitted into memory of a standard support cluster, and SwarmX is needed to distribute the training across multiple systems. So small models can run with support system, large models need MemoryX, large models distributed training need MemoryX and SwarmX.
I love that. We got 3 answers, each of which shorter than the last. And that's actually all the open questions I have, I think. Has anyone else got questions I missed? If now's the time to speak up.
I'd like maybe to discuss a little bit and come back to the question about using CSL as a backend for machine learning applications and how we can provide a capability to the users to write custom kernels. That's definitely top of mind for us, and I think that's a really important capability for making. There is no way that our team can write all possible kernels in the future, so we understand that, and that's definitely on the roadmap. One thing which can be done today is using CSL today to write primitives which we believe will be useful for different kernels in machine learning in the future, and start thinking how you can map those primitives onto the hardware using CSL, and maybe also work with us to help figure out the requirements for their integration of those kernels later on into machine learning runtime. So if there is a way to, what I'm trying to say, if there is a way to distill a specific kernels for specific operations, which will be needed for machine learning kernels in the future, I think it might be interesting to test those right now with CSL, even given the fact that you can't integrate them into machine learning runtime. But that will give some proofs that once that capability is there will be a way to have very high performance component for a specific op, which will be needed in a neural network. And if you have some inputs on how that's the whole thing should look like, also please reach out, and I think it will be good to collect that feedback as we plan on how to embark on integration of custom kernels into machine learning runtime.
Okay, thanks, Natalia. We've got one from Jim Edwards for Justin. We are interested in working with the NETL WSC _ interface, but it seems to require a different SDK than this one. Could you talk about that?
Yes, so for those who are not aware, Nettle, who is actually on this call, the folks from Nettle, have created a Python domain-specific language for solving field equations. It has a Python look and feel, and it allows you to express these equations pretty easily, and you get very good performance on the wafer scale engine for these sorts of applications. So Actually, what I would recommend is for folks who are interested, you should reach out to the Nettle folks and Dirk, and I think Brian as well. But yeah, we'd be happy to help facilitate those conversations as well. This is unrelated to the SDK and is sort of the first instance of a domain-specific language that we hope to build more of these on top of the SDK in the future.
Oh, interesting. Okay, and then from Cathal O'Brien, again, Cathal, forgive me if I'm mispronouncing that. Will the BLAS CSM implementation be released in version 0.4 of the SDK?
Okay, so in version 0.4, we're going to be, we won't have the BLAS library, but we're going to be following up very soon with a gem kernel, which it would be part of BLAS. And so this is a capability that we will continue to build out into the future.
Can you say a bit more about that, Justin? That gem is a subset of BLAS?
It is one kernel out of the many BLAS 1, 2, and 3 kernels that you might want to run HPC applications.
Okay, thank you. See, I get to ask questions too. Okay, I think we're all caught up.
We can use the next few minutes if anyone wants to hop on the mic and ask a question, as opposed to entering it in the chat. You can hear your voice as well.
In addition to that, it might not be necessarily a question. As you see, we are bootstrapping this developer community meeting, and it's intended to be a community. It doesn't mean that that's Cerebras talking and no, everyone is listening. So any input and feedback, what resources do you think are missing? What kind of help do you want to see from your peers? What kind of communication will be helpful for you? Let's discuss and let's talk about that.
Okay. Do we have a Slack channel? Asks Sid from NCAR.
For the developer community at the moment, we do not, but that is definitely something we are considering and working on. So stay tuned for that, Sid.
So Uday means not yet. But we know you want it and we want you to have it.
The writing's on the wall.
Writing's on the chat window. That's a good idea, Mohammed. Thank you.
Any specific preferred platforms to host the blog? Do any of you use some of the, what are examples of the blogs or mechanisms that you used for some other forums and you like those?
Right, rather than just ours. So I'm sure everybody here reads our blog every time a new thing comes out, right? Maybe not. Oh, Alice.
Discourse.
Yeah, discourse. Thanks.
And Alice has a question. What is this is a good loaded question. What is the teraflops rating for the CS2?
So the peak performance is around, we actually just decided that we've never talked about that publicly, but we have a submission, paper submission, which I think first reveal that number. So the peak flops number for CS2 is slightly above 5 petaflops, but that's dense FP16. So the reason why we didn't share that before, because we believe that peak flops are not the good characteristics of the hardware. So we want to be able to talk about end-to-end performance for the workload. That's a better metric. But I understand why it's useful. So essentially, we can talk about specific details of their cores, and we share the instruction ICA. We share a lot of details about the hardware already. So we can share that information as well. I think you know how many processing elements are there on CS2 machines, so wafer scale engine generation 2. We have kind of SIMD instructions, fuse, multiply, adds on the system, and essentially you can derive the peak flow from that information.
Yes, it's not just a question of how many flops you have, it's what you do with them.
Yeah, and how you can use those. Can you use all of them? That's
Yes. Right. Nobody
and I think
likes
that's exactly
to
the reason why NVIDIA also, it's a blowed up metrics. So NVIDIA sometimes published right now, they call it, I don't know, AI flops, assuming that they can leverage 50% of sparsity, but why 50%? Who said that you can leverage 50% of sparsity? Many other hardware also try to, I don't know, it naturally blew up the flops, which is, you know, hard to estimate.
So Sid has another good question that I actually had to Google. Did anybody try HPCG on CS2?
So we, yeah,
go ahead.
go ahead, Justin.
Oh, so I was just going to say, not that we're aware of, but it is something that actually, no, we did have a conjugate gradient application being built. Is that right, Natalia? Yeah.
Yeah, so we didn't run exactly HPCG, but as part of this NETL work, which has been mentioned already, we wrote biconjugate gradient descent, which is very similar to HPCG, but not exactly the same. So we have an example of biconjugate gradient descent on running on CS1, CS2. Something actually to maybe think about, that example has been written using low-level programming tools, so it doesn't use CSL. So we may consider actually having either a HPCG or biconjugate or any other type of similar algorithm implemented via CSL.
Sid, if you want to write HPCG, we'd love to see that.
We've got 5 minutes left, so Uday, why don't we wrap up?
Yep. That was a great set of questions.
I know.
I didn't expect to get, double digits. That was awesome. Thanks to everyone who asked questions and yeah, contributed to the chatter. Appreciate that. So just a couple follow-ups after this meeting. We'll probably send an email out with this, letting you know about this information. But just so you have it here, if you're interested in keeping up with all of our activities and announcements, we'll post in the chat here how you can subscribe to our newsletter. As I mentioned at the beginning of the presentation, we have a survey that we'd love for you to fill out. And Rebecca has already posted the link to that. So if you'd be interested, feel free to take our survey. And if we didn't answer any of your questions, or if there was a question you didn't share with us today, but you'd like us to answer, feel free to send us an email at developer@cerebras.net, and we'll be happy to respond that way as well. With that said, I really want to thank everyone for attending today. I hope this was as informative for you as it was for us. I'm sure we have a ton of feedback now. That was great. And we really, really are excited about this first one and for all our future meetings to come. So appreciate your time. Thank you all. I hope you guys have a wonderful day.